Today we're going to talk about the content in basic genetics that we treat in grade 12, variation and selection. It is important that whenever you do your planning and learning for a subject, that you always go back to the policy documents that is available. For this purpose, there are two documents that actually guide your planning and your learning and teaching. That is the so-called the CAPS document, that is the curriculum assessment document, and then also the examination guide. And if we look at the examination guide closer for this content topic, we actually state that we need to look at our content by defining and explaining genetic terminology that we use in variation and selection, that we identify and describe the importance of variation and selection, that we discuss the external and internal genetic aspects, and lastly, we're quickly going to look at selection itself, the types and the methods that we use in agriculture for plant breeding. If we look at our aim, it is important that at the end of your lesson, that you should be able to use terminology in variation and selection appropriately, that you understand variation and selection in the context of agriculture, and lastly, understand and apply the selection methods and types. Right through this whole document or presentation, we are going to refer you back to some activities that we are dealing with. Our first activity is a word challenge. We will discuss it a little bit later on, that you need to have available during the lesson. We're going to talk about activity 2, that is a crossword puzzle that you need to have in front of you during the video that we're going to show you. Then we also have, to support learning and teaching, we're going to have a worksheet that needs to be completed during the lesson, and as an alternative activity we do also have a matching activity and also homework and classwork. In any content lesson there is a lot of words that is important for us to, and for you as learner to understand. As we've just said, this lesson is about selection, so you need to make sure that you understand the meaning of selection. In this context that we're going to deal with, selection is an act of choosing from the whole. In other words, you select individual animals. If we talk about breeding, it is the process where we do mate animals in order to produce the next offspring. But if you look at the first part of the word breed or breeding, it also implies two different meanings. A breed can also be a group of animals with distinct characteristics. They do belong to each other. Or we can say it is the mating process where we breed a male and a female in order to produce an offspring. There is other words that's also interesting that we need to look at, and that learners, you as a learner, need to understand, such as desirable, that is pleasing, qualitative, quantitative. And for the purpose of this lesson, it is important that you make sure that you understand the words and the context in which they are used in selection and breeding. Why is variation and selection so important? It all is about food production. It's been estimated that the world population by the year 2050 will reach 10.5 billion people. Those people need food. Our resources, that is our soil or our productive soil that we use or do have in order to produce soil, our crops is not that much, so we are running out of those type of resources. So we need variation and we need selection in order to make sure that enough food is being produced. If we look at the maize plant with a history of 3,500 years, the first maize did not produce that much. But today the modern corn produce enough food for all the people in the world, as maize is a staple food. And that is only through the process of selection and breeding. So if we look at variation and we need to define variation, we say that variation is a difference or a deviation from the group. In other words, if we do have a group of people and we compare them with one another regarding length, we all have different lengths. We all have different traits, we all have different characteristics, and those things refer to our variation. Now, why is that so important in selection? In selection, the variation is actually the material the breeder do have available for improvement that you can choose from. Variation is also then caused by genetic causes or environmental causes, wherein genetic causes are those that you do inherit from your parents, and that can be grouped into three groups through sexual reproduction, that during the process of meiosis, crossing over of genes take place. That creates variation as itself. Sometimes we do find DNA mutation where there is a complete change in the DNA structure, and then gene migration where new genes are introduced into a population as organisms migrate into a new environment. If you look at environmental causes, that is variation as it is caused by the environment itself. Simple example, if you eat too much, you're going to gain weight. Certain flowers like the hydrogenia, they only produce blue flowers in acid soils and pink flowers in alkaline soils. That is the environment that play a role, and is not because of inherited factors or internal factors. Variation can also be discontinuous or continuous. If we look at discontinuous variation, there are distinct classes of phenotypes for a particular character, and as you have learned during previous lessons, the phenotype is what I can see. It is not something that is hidden, and the phenotype or discontinuous variation can be represented by a bar graph. Some examples for discontinuous variation is things such as height, color, and we will height, color, poultness, and then horns that animals do have. If we look at continuous variation, we do have there an unbroken range of phenotypic values. In other words, we can stage them and we can get a line that we can draw on a graph, and therefore we can say that a line graph is used to represent continuous variation. Look at some examples. It is such as height, body weight, heart rate, milk production, and growth rate. We will look at some other characteristics of each of these variations. There's some of the samples that you can see. Polled, that is animals that's been born without horns, and that's because of a mutation that we find in a group. Color in cattle, different color do we find over the spectrum of all the different cattle breeds that we do find in the world and even in South Africa. Continuous variation, as we've said, we can draw a line graph on that. If you look at the graph that's on the screen, you're going to notice that 2% off on either side, either on above the 1 is unacceptable, and if you look at number 5, 2% is outstanding. Where 2 and 4, 2 means room for improvement, that contributes to 14% of the population, where 68% of the population is average or meets the expectation, and 4% exceeds the expectation, that's 14%, and then 2% that is outstanding. That bar graph is also known as the norm distribution or the bell curve, and that shows the variation as we do find it in our population. To give you some examples, this is application as we do find it in agriculture on the screen. We do have two graphs. The one is for milk yield. In other words, that is the amount of milk that is being produced by a dairy animal during a year, over 250 days, the amounts of liters. And on the right, we do have body weight. And if you look at the distribution, we can clearly match the bell curve or the norm distribution curve that's been showed in the previous diagram. We do have 2% on the right and the 14% that is unacceptable. Then we do have the green and the light blue, that is the average and above average, and then the dark blue on the far right that contributes to 2% of the population that is far above the average that's been produced. Variation influence also our traits. We do find qualitative traits and quantitative traits. Now, qualitative traits are those things that you can see. Those are also the sharp distinction between the phenotypes. It's also the yes or the no trait. You have it or you don't. A cattle do have horns or it don't have horns. That's how we can easily distinguish between our quantitative traits. It's the simplest type of inheritance, your quantitative traits. It is also monogenetic in nature because it consists mainly out of one or two genes, and then the environment has very little influence on these type of traits. If you look at quantitative traits, that is caused by continuous variation. Those are things where we do find more than one trait is playing a role. They are then known as polygenetic traits. It's normally your most economical traits that do play a role, such as milk production, growth rate, feed conversion, where a couple of genes do play a role in order to get to all that where the traits has been expressed. And we do say that environment also play a huge role in this type of gene. Then why is selection so important? In selection and breeding, people select the material, animals or plants, that will produce the next generation. We can actually graphically explain it like that, and for each selection we do have a selection response. On the graph we do have two bell curves. The top we do have the parent material, and in the bottom we do have the offspring of the generation. That is the next generation. In the top graph you see that here is a group of animals that is being selected, and the blue line represents the mean of the selected animals. So the mean actually is the average of that group of animals. So if we breed those animals, as we've said earlier under our wording, we then see that in the bottom graph, the green line is actually the response in the direction or the selection process that the generation do have. And we then therefore can say that prediction genetic gain is about predicting the future. How much better will the offspring compare towards its product, towards its parents? But we also need to make sure that traits need to be heritable, and they do have different heritability. In other words, not all traits are inherited in the same percentages, and that is important in our selection response. So we can then say that the superiority of the selected parents in comparison to their generation is called the selection differential, and the superiority of the offspring in comparison to their parents is called the selection response. In any success of selection and breeding, as we've said, the traits need to be heritable. As we've said, the higher heritable your trait is, the quicker selection response will be, and the lower heritability will lead to a longer process that you need to do selection. Breeding programs within agriculture actually yield sharp increases in the quantity of food produced. On the screen you're going to see the improvement in food production in the broiler industry. In 1957, there you can see the carcass of a bird on day 43. In 2003, the same breed, but with selection and the process of selection. Nowadays, we actually slaughter broilers on day 57, and in the past, in 1957, we only slaughtered at day 85. Why is that so important? Economical costs. You can put more broilers through the broiler house in a shorter time frame if they do grow quicker. So selection is merely based, or the main reason for the quantity of food that is being produced. We also say that breeding activities and selection are directly influenced by the development of the society. What does that mean? What do we need? In the pictures that's on the screen, you do have a picture of a leading sow. It's the Poland-China sow in the 1900s, in the year 1900. And in 1990, we given you another example. Look at the conformation. Many people use the fat of pigs to cook soap from. Nowadays we don't need it because we go to Pick n Pay to buy our soap. Then for the lazy and the environmentalists, we do now find featherless chickens because we don't have to get rid of the plumage or the feathers after or during the process of slaughtering. We also find different dog breeds. We have different choices in the type of breed of dog that we kept for various reasons. Some people have more land available, some people stay in flats, so that will depend on the type of dog that you can have. Breeding activities do not also go the way that we intend it in going. So if we look at an example, in the past we have seen that there were two types of Hereford cattle, a normal type and a compressed type. Cattlemen actually like the compressed type because when they breed them they grow quicker. But when they selected those type of cattle in order for breeding purposes, we find an extreme type of dwarfism that actually occur. And that is another lesson that you will experience, the breeding, inbreeding, line breeding, that do play a role later on in the syllabus. So we can then say that through variation, selection is the hope in producing a better offspring. Through this whole process, natural selection do play a role, and it is important for the adaptation of animals to the circumstances in which they are kept. We are now going to watch a DVD or a video, Meet the Super Cow, in which some of the selection principles that we've been discussed is shown. It is also important that many of the content or pre-knowledge that you have gained through reproduction, animal reproduction, and the techniques in order to breed these type of animals, what is being used. And it is best that you do have activity number 2, that is the crossword puzzle, with you, and see if you can complete the crossword puzzle as you do go through the DVD.
In the cowshed, the man in charge of the beef herd is Patrice Lobe.
He's a big fellow. Am I all right?
He's quite big, huh? He's 160 meter tall, yeah.
If I saw a man like that,
Yeah.
but I wouldn't get this close to him, I don't think. I would think he was on steroids or something. I think
No.
he was a bodybuilder.
It is 100% natural, whereby, let's say, within so many generations, our breeders have taken the best of the best, or the more muscle of the more muscle. We moved from a normal classical type of animal, and then we select that sort of animal based on the double muscle.
And when you say double muscled,
Yeah.
do you mean it has two of every muscle?
No, 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 no.
Because it looks like it does in
Absolutely.
almost.
It has exactly the same type of muscle than any other breed, except that in terms of quantity, each of these muscles is by far more developed.
Right. This cow is technically known as a Belgian Blue, and it's the product of selective breeding.
Selective breeding is the first stop on our tour of how man is using science to control nature. It's used by farmers to enhance desirable characteristics in their animals. In fact, selective breeding is all about managing sex. To create these Belgian Blues, over 100 years, farmers have only allowed the cows and bulls with the greatest muscle mass to mate. And the result is a bull that weighs over a ton. The animal's breeders are keen to show off the results of their hard work. The bulls are shaved to best display their muscles.
What they try to do is to clip the animals in order to highlight all the muscle. You see?
Well, so you can see where all the meat is. That's going to be.
Exactly.
But even here, where they've sort of trimmed in there.
Yeah, to highlight that muscle, which has got a high value. You see?
And these are all going to be lean cuts, and they're all for quick cooking, are they?
That's right. That's right.
Because when you look at this, you can't help thinking of lunch, you know? Is it healthy?
The animal, you mean?
Yeah.
Well, the animal is as healthy as another intensive producing animal.
So this is about the most technological that meat can get?
Not the most technological. In terms of technology, we talk about selection, natural selection, having achieved that.
So what is the science behind the Belgian Blues? There is a gene that regulates the growth of muscles in cattle. These cows have been selectively bred from animals that contain a copy of this gene which doesn't work. As a result, their muscles grow far larger than normal. To ensure the defective gene is passed on, sex for the Belgian Blues has been replaced by technology in the form of artificial insemination.
He is basically a sperm machine.
He is a sperm machine, absolutely.
It's very early in the morning for...
I understand.
The semen is now collected, it's in the artificial vagina, and from there we will process the semen in order to be able to process artificial insemination on the cow.
So precise is the technology involved, they can analyse the semen sperm by sperm to choose the ones they want. So this is what this is testing the sperm count.
That's a sperm analyzer. It's now checking, let's say, the quality of the sperm we have been collecting this morning. Green is good because you see that they are very, very mobile and they are looking forward to move towards the eggs.
And these are not especially muscly sperm.
Don't you find that they are very muscled?
Well, they look impressive to me, but I've never seen any other bull sperm. No.
Visually, you won't see any difference. There is no way to find any difference between the bovine, the equine, and the other species now.
Right.
Let's quickly look at natural versus artificial selection and a quick comparison. Anything that is done man-made is artificial. Anything that is done by nature is natural. It's basically as simple as that. So natural selection takes place without the human interference. Natural selection leads to survival of the fittest. And we also find that when you can survive, you are adapted to your circumstances. And we find that there is no genotypic involvement in natural selection. It is all about, it acts on the phenotype. When we talk about artificial selection, we say that humans select which traits will be passed on to the next generation. We find humans and breeders routinely used nature-provided variations in order to select useful traits that they then can use to produce better animals and better plants. And artificial selection acts on the phenotype and the genotype. What is the next role that we find, or the next selection that we can then discuss? We're quickly going to refer you to selection types. On the screen, you're going to see 3 types of selection. We've got directional selection, stabilizing selection, and disruptive selection. Each of those important in its own right. As we've already seen and mentioned earlier, in selection there should be a plan. You need to go what direction I want to go. And here we can see that is it directional selection, there is a specific purpose. I need to improve. If it is stabilizing selection, I need to stabilize the mean or the average of the group of animals that I'm working with. And for each of those, we're going to look at some examples. We're going to look at some, in agriculture, the way that it's been implemented. And the other one is we've got disruptive selection. What is the main reason? Why is disruptive selection actually? Why does it exist? So in directional selection, if you can look on the screen, you will see that there's an orange line above the mean. In all of these 3, you look at the short, the medium, and the long. That is the different types of population in the spread of the trait in your population. All right. In directional selection, we select for one extreme trait, or we select for a couple. Let's, for example, we say that we select for improved weaning weight. So the parent material, as we've shown earlier under the discontinuous graph or continuous graph, we showed you that we're going to select the best animals because we want to move to the right. And then if we look at the population, the original population, that gives you the mean of the average. And if you look then at the green line, that gives me the move of the population average to the right after selection. As we've said, we look and select for one extreme trait, and we select against other extremes. If we look at some examples in directional selection, there we see an example of weaner calves that is actually being bred through the process of directional selection. So there's always a reason and a plan why we do that. In stabilizing selection, we don't want animals to become bigger or calves to become bigger because that poses problems in itself. So here we try to narrow the average or the mean of the group of animals. And if you look at the original population that represent the spread of the mean by the 2 orange lines, and then if we, after selection, find it in the highlighted area and the green lines, you see that the mean or the average spread is now much closer. In other words, the majority of animals do have the same or are closer to the average than the previous population. So we select for moderate traits. We don't want traits that is actually too extreme that can influence that average. And if we look at some examples there, in birth mass is a specific example there. We don't want calves to become bigger because, as we've seen in reproduction, bigger calves can lead to dystocia. That can lead to calving problems, and calving problems in itself can cause problems of pregnancy and in your herd. Another example that we've got there is also mature cow mass. We also don't want cows to become bigger. Bigger cows eat more. The more they eat, the more food you should buy, and you're not necessarily get the same production from them. So we would rather go for cows with an average weight but work on the production capabilities of those animals. The last one what we've got is disruptive selection. In disruptive selection, we actually select for both extremes and we do select against moderate traits. If we look at some examples, we there see that a miniature and normal size cattle is actually originated from that. Miniature Brahman cattle is basically knee height. Why is that then important? Some people don't have large areas of land, so they would prefer to play around with these small things. You don't going to have big herds. They not really produce meat, but they are there for pet purposes. And then you do have the normal Brahman or sized cattle. And if you go to the internet and see how many different types of miniature cattle there is, it is quite astonishing to see what breeding and selection has actually achieved in the last couple of years. The last thing that we're going to look at is selection methods that we use to change these traits. We're going to follow methods such as mass selection, pedigree selection, progeny selection, and then also family selection. Mass selection is based on the individual animal's performance for a trait in a population. In other words, the individual animal is being measured against the group of animals. So it's easy to choose the best animals in the specific trait because you do have a frame of reference. That's how they compare with the group, and you will use the best for the specific trait. Pedigree selection is based on the quality of the animal's ancestors. All right, here the animal has done nothing as itself, but the performance of his parents and his grandparents has actually played a role in making him being selected. If we look at progeny selection, is based on the quality of the animal's offspring. Here, the offspring is tested when they are in the production stages. It's been usually used in dairy breeding, where heifers is being tested for their milking abilities, the amount of milk that they produced, and based on the progeny of a specific dairy bull, he can then be semen can then be distributed through the whole production chain. The last one that we're going to look at is family selection, where the selection is based on the quality of the animal's relatives in each generation. So basically the same as pedigree, but there is a wider net where the parents, the brothers, the sisters, half brothers, half sisters are all joined together in order to make a selection decision based on the animal's performance. I hope this had given you some idea about variation and selection, what we need to know for the content and for basic genetics. But the important thing is, in agriculture, these things need to be seen in context, all right, how it's been applied, and as I've said mentioned earlier, it is important that you look at the examination guide to see how deep you need to go into the understanding of the specific content. Thanks.